Alright, this is question number 6 on the 2011 Form B test. And this question is asking us to find, for part A, the antiderivative f of x. So if we write down what that says, going from negative 2 pi to 4 pi on f of x, which has got two terms in it. So if we wanted, we could break it up and write it as two separate integrals and see if that helps us at all. Since the function f of x has got some really distinct pieces, I think looking at it this way makes a lot of sense. So now we do the antiderivative of g of x. Well, this is g, and so we know that the antiderivative of g from negative 2 pi to 4 pi is just going to be the net area under the curve. So this portion is simply going to be 1/2 of the base, which is 6 pi, times the height, which is 2 pi, which gives me, let's see, half of 2 cancels out, what, 6 pi squared, minus, and now a more traditional antiderivative, so minus the antiderivative cosine of x over 2 is going to be sine of x over 2 times, let's see, 2. So let's check that. I take the derivative of sine of x over 2, I get cosine of x over 2 times the derivative of the inside, which is a half, which cancels out my 2, and we're good. Evaluate it from negative 2 pi to 4 pi, and so that's going to give me just this portion is going to be 2 times the sine of 4 pi goes in here, the 2 reduces, and I get 2 pi minus 2 sine, I'm going to put negative 2 pi in, negative 2 pi over 2, which is going to be negative pi, and the answer in both of those is 0. So unless I've done something really, really wrong, the answer for that portion is 0, and the answer to the whole question is simply 6 pi squared. Alright, I took up a lot of my working space here, so I'm just going to erase this. Part B. Find all the x values in the open interval for which f, again f is defined as g of x minus cosine of x over 2, all of the places where f has a critical value. So that means I would take the derivative of f and set it equal to 0, or take the derivative and find when it's undefined. Okay, so the derivative of f, do it term by term, is simply the derivative of g minus the derivative of cosine is negative sine, so plus sine of x over 2 times the derivative of x over 2, or 1/2 x, which is times a half. So here's my derivative, and I want to know when it's equal to 0 and when it's undefined. So this could be a little challenging here. As far as when it equals 0, I would need g prime of x to be the opposite of this part. So g prime of x is just the slopes of g. So let's come look at g. The slope here for this portion is 2 pi over 4 pi in the negative direction, which reduces down to negative 1/2. And the slope here goes from 2 pi to 2 pi. That should be a slope of 1. So there's really two problems I need to solve here. I need to know, again, focusing on the 0 portion, I want to know g prime of x, we'll call that 1, plus half sine of x over 2. I need to solve that problem, but I also need to solve and find the answer to this question as well. Again, since the slope changes, but it's only 2 separate values, that means I need to find out, when half sine of x over 2 equals 1 and when it equals negative a half. Interesting. But then also, I only care about it equaling a slope of 1 between negative pi, 2 pi, and 0. So if this slope equals negative 1 somewhere else, I don't think I care about that. Anyway, I'll cross that bridge when I come to it. So let's solve this problem. Subtract 1 multiplied by 2, and I get negative 2 equals sine of x over 2. I think I can stop right there because sine of x over 2 will never equal negative 2. X over 2 is going to change the period of the function, but I'm more worried about an amplitude. Sine only goes to 1 to negative 1, and so I'm never going to reach this. So there is no place where the slope equals, at least, what am I trying to say? So there's no place where we're going to have an issue because of the slope of 1, because nowhere does 1/2 sine of x over 2 satisfy that. So now we got to see if it ever equals the other slope of negative a half. So I'm going to add a half, multiply by 2, and if I'm not mistaken, that will give me 1. It's really late and I'm really tired, so I could make some silly mistakes here. So add a half, multiply by 2, and that's 1. So I need to answer this question. Sine equals 1 at when x over 2 is going to equal pi over 2, when x over 2 is going to equal 2 pi, 3 pi over 2. So what am I doing here? I'm looking at the graph of sine. So actually I just made a mistake. It's not 3 pi over 2. So here's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So it's going to equal 1 at pi over 2 and at 5 pi over 2. And then the next time would be, let's see, starting on, so that'd be 6 pi over 2, 7, 8, it would be 9 pi over 2, which is outside of my window here. So now the question is, do I want to look to see when sine is going to be equal to 1? Alright, so the issue is that this equation formed because we had this slope of negative a half, and that's only occurring here. So my window that I should be looking at to match up with that should be in that same window. I shouldn't be looking in the negatives. At least that's my theory. Okay, I gotta quit talking and finish this question. So I get x equals, multiply by 2 on both sides, and I get pi. Multiply by 2 on both sides, the 2's cancel, I get x equals 5 pi. Again, though, that ends up being outside the window. So I got one place where the derivative of f equals 0. But now I need to look for undefined. So is there anywhere where this piece is undefined? The 1/2 sine of x over 2, and the answer is no. Is there any place where the derivative of g is undefined? And the answer to that question is yes. The derivative of g is not defined at 0. So I have another critical value of x equals 0. Okay. I'm not 100% confident in that answer, but I'm reasonably confident. Okay, part C. So let h of x equal 0 to 3x g of t. Okay, so then they're asking me to find h prime of pi over 3. Alright, so this is kind of an interesting question because they're telling me that the antiderivative of g is going to be h, but they're not asking me for h, they're asking me for the derivative of h, which should be g. Although the 3x complicates matters. So let's do this. H of t is going to equal, I'm going to call it the antiderivative of little g, let's just call it big G for now. We're going to evaluate it from 0 to 3x. So I get a function that says little h of t is big G of 3x minus big G of 0. Alright, looks like a C7. Okay. Crap, now I'm always going to see that as C7. Okay, so there's G of 3x minus G of 0. But now what does it ask me to do? Take the derivative of h and evaluate it at pi over 3. So the derivative of h means do term by term. I get the derivative of big G, which is little g of 3x times the derivative of 3x, because of the chain rule, times 3. The derivative of a constant g of 0 is 0. So here's my function. I need to plug in pi over 3. So I get g of pi over 3 times 3 is going to be 3's cancel. I get g of pi times 3. So this will be my answer if I can evaluate it. So then I go back and look at the picture and I see that this is g. 1 pi, 2 pi, 3 pi, 4 pi. I need the answer to this value right there. So my slope is negative a half. So that means I've gone down a half and over 1. So this point at pi over 3, I'm sorry, at pi, is going to be down a half from 2 pi, which should be 3 pi over 2, because that would be 1.5 pi. So g of pi is 3 pi over 2 times 3. The answer should be 9 pi over 2. Oops, made a mistake. Negative. I got to plug in negative pi over 3. So I plug in negative pi over 3, I get negative pi. Okay, so what I just said there was awful. So now I go to g of negative pi, which is going to simply be pi. Up a pi over 1, up another pi over 1. Okay, so g of negative pi is pi, pi times 3. Now I think my answer is 3 pi. Alright, this isn't the hardest question we've done, but it ranks up there as probably the most confusing for some of you. Let's see how, well actually I have no idea how people did because this is a Form B. Alright, let's see if we get the right answers. 6 pi over 2. So that's correct. 1 point for the antiderivative, so doing this work. And then 1 point for the answer. I kind of feel like we deserve a little bit more than just 2 points, but that's just me. Part B, 0 and pi. Those are the two answers I got, so all of this should be good. And then part C is 3 pi. Okay, so this was my least favorite question, but I at least got myself a 9 on it. Okay, that's it for the 2011 Form B.